Alright guys, so today we're doing section 3.2 or lesson 3.2, solving exponential equations without logarithms. If you don't know what logarithms are, well, we'll get to them in a day or so. This is without logarithms, so that means you don't have to worry about that. The main point is we're solving exponential equations. Now think about solving equations in general from algebra 1, algebra 2, 5x plus 3, that's supposed to be a 3 equals 9, you subtract 3, divide by 5, and you're done. I mean, that's the basics of solving an equation, and you want to isolate x. Same thing, except we're doing exponential equations, which yesterday we graphed exponential equations. The main thing is that you have a variable in the exponent. That's what makes it an exponential equation. So if we're not using this thing called logarithms, which as far as you know are just magical, mythical creatures, I don't know, what are we going to do? We're going to use something called the one-to-one property, which I'm going to preview right now. If you had 5 to the x equals 5 to the 7th, that's given to you. That's your equation. Well, 5 to the x equals 5 to the 7th. Well, 5 clearly equals 5. Therefore, the x would have to equal 7. It's like saying, oh, these 5's just cancel it out, and you get x equals 7. So that's the one-to-one property right there. The 5 on each side, or the same number on each side, there's a one-to-one correspondence between them. They just cancel out, and what you're left with is your equation. We're going to use some basic algebra steps, basic algebra order. That all still applies to solving an equation. It's just this new one-to-one property is going to come into play at some point. We'll get into some harder problems where we'll have to change the base, so I'll talk about that when we get there. There are special cases where you can have no solution or all real numbers for solutions. We'll get to that when it comes up. Not going to worry about it right now. We will have to be doing some combining bases, and I'm not going to wait till that comes up. I'm going to talk about that right now. In algebra 1, algebra 2, you talk about things like x squared times x to the third. When you combine that, that's x to the fifth. When you multiply like bases, you just add those powers together. Well, the same rule applies in exponential equations. It just looks different. But these bases are the same. They're both base 2. So the answer is going to be 2 to a power, and the power is what you get when you add these two powers together. So x plus 3x is 4x. 1 plus negative 5 is negative 4. There, I've just combined the bases. Now, this is going to be a step in a bigger process. The bigger process will be that this is an equation, and then we need to solve it. But that's just an example of how you can combine bases. Here's another example of combining bases. In basic algebra, you have x to the fifth over x to the third. Do you remember how to simplify that? If you said subtract the bases, you are right. 5 minus 3 is 2. So when you divide like bases, the rule is you subtract the powers. Same thing here. We have like bases, 2 over 2. So you keep the base and subtract the powers. What is 5x plus 1 minus x? Well, you can do like terms. 5x minus x is 4x, and then bring over the plus 1. And there, we've just combined those bases. So that's a thing you have to keep in the back of your mind when we get to some of the more complicated problems. But they do not start complicated. They start fairly simple and straightforward. So number 2, this is an exponential equation. It's an equation because there's an equal sign, exponential because the variable is in the exponent. How do we solve this? Quite simply, the common bases cancel out. You get 3n equals negative 3n minus 2. And now it boils down to an algebra 1 problem, something you could have done in 8th or 9th grade. Add 3n to both sides. You get 6n equals negative 2. Divide by 6. Now 6 does not divide into 2, where this is going to be a fractional answer. You can reduce 2/6 to 1/3, and that is it. N equals negative 1/3. Let's check the answer to number 2. And there it is, negative 1/3. Number 4. 5 to the negative 2x equals 5 to the 3x. Again, the one-to-one property says if those bases match, you can just cross them out. You get negative 2x equals 3x. Combine like terms, so I'm going to add 2x to both sides. I get 0 equals 5x. Divide by 5, x equals 0. And there it is. Again, now these start off really simple. They're going to get much more challenging as we go. If you're the type who turns off the video after a couple examples, that might not be smart here. You might want to fast forward and look at some of the harder examples before you get to work. Just saying. All right, number 4. Let's check number 4. And there it is, 0. Let's do number 5. Nope, number 6. I'm smart. Again, the common bases cancel out. 2x equals negative x minus 3. To get like terms together, I'm going to add x to both sides. 3x equals negative 3. Divide by negative 3. So see what I meant when I said basic algebra steps will come into play. I'm doing all basic algebra steps right here. Negative 3 divided by 3 is negative 1. That should be the answer to number 6. Let's check and see. Ugh. There it is. I hate all this scrolling up and down. You know what? While I'm looking at this, number 8 is going to be all real numbers. So here's a preview of number 8. It's going to be all real numbers. Let's do number 8 and see why. Okay, so one-to-one property, those cancel out. You get 2p equals 2p. Basic algebra now would be to combine like terms. So I'm going to subtract 2p on both sides. I get 0 equals 0. And you may recall in an equation, if the variable completely disappears, that means one of two things. It's either all real numbers or no solution. You just have to look at the result. Does 0 really equal 0? Yeah, this is a true statement. So all real numbers is the solution. That's how you get an all real numbers. You end up with 0 equals 0, or maybe you'll have 5 equals 5, 1 equals 1, something like that. All right, number 10. Now, number 10, the one-to-one property does not directly apply. This does not equal this. You cannot just cross them out. It does not work that way. So there's got to be a trick. And there is. This is in my notes up here what I referred to as change the base. I'm going to show you how to change the base here. Now it takes a little trickery. It takes a little ingenuity on your part. It might take a calculator. I'm going to pull up Desmos just to have it, just in case. I don't necessarily need it, but it might be good for me to show you how you could use it if you were stuck. So I just happen to know that 125 is 5 raised to the third power. See, 125. And 625 is 5 raised to the fourth power. So what I can do is I can make this 5 to the third, 3a minus 3. And over here, make this 5 to the fourth. And, oh, there is no power here to bring down, so I just leave it like that. Now I can use the one-to-one property to cross those out. I get 3 times 3 minus 3, 3a minus 3, equals 4. Now it's a basic equation again. So the bases didn't match each other from the beginning. The fact that they both ended in 5 gave me a little tip-off that those are powers of 5. Use the calculator to figure out what powers of 5 they exactly are, and then cross out the 5s. Now to solve it, distribute here. 9a minus 9 equals 4. Add 9 to both sides. 9a equals 13. Divide by 9. Of course, 9 does not divide into 13, so 13/9 is probably going to be the final answer. I say probably because oh, there it is. I mean, it could be 1 4/9, you know, but whatever. Okay, there it is. So there's a change of base. Let's do it again. Now, 243. That number may not jump out at people. It's not an even number, so it's not going to be 2 raised to some sort of power. That's just not going to be it. So let's try 3. And here's an option. 3 times 3 is 9. Oops, 3 is 9. Times 3 again, 27. Times 3 again, 81. Times 3 again. Just keep doing. Oh, look, 243. How many 3s did that take? 1, 2, 3, 4, 5. So this is 3 to the 5th power, negative x minus 3. Now, just a minute ago, just a second ago really, before I put in that last times 3, that was 81. And look at there, 81. So that's 1 over 3 to the 4th power, 1, 2, 3, 4 3s. But this is still a bit of an issue. This base is 3. This base is a 3, but it's underneath a fraction bar. In order for the one-to-one property to kick in, these both have to be regular 3s. I can't be 1/3. So I can't have 1 over 3 here and cancel those out. just need this to be a 3. Well, there's another rule of exponents, which maybe you remember from Algebra 2, maybe not. If you don't, here it is. Here, I'm going to use the calculator to kind of prove my point. So 1 over 81, nope, 1 over 81 is that 1 over 3 raised to the 4th, same exact thing, right? Now check this out. 3 raised to the negative 4th power. Yes, there's something called the reciprocal rule or the negative exponent rule when it comes to exponents, that if you have an exponent in the bottom of a fraction, you can take it out of the denominator, but you have to make it negative. So whenever you do problems with a denominator like this, just assume at some point you're going to have a negative exponent. Will we have more examples of this? Yeah, right here. And is there an... well, that's not really. But yeah, it'll come up again. Okay, so what do we do now? Well, 1-to-1 rule, those 3's cancel out. That gives me 5 times negative x minus 3 equals negative 4. Distribute the 5. Negative 5x minus 15 equals negative 4. Add 15. Negative 5x equals 11. Divide by negative 5. X equals negative 11 fifths. Should be the answer. Check number 12, and there it is, negative 11 fifths. All right, so if you have a base that's in the denominator of a fraction and you don't want it to be a fraction, you can just make it not a fraction, but you have to switch the power to a negative. That's the negative exponent rule. Google negative exponent rule if you need to learn a little more about that. Okay, let's do number 14. Let me erase that. Make it a little more presentable. There we go. So again, these are different bases, but we can make them the same. You probably just have basic knowledge in your head that 25 is 5 squared. Just a few minutes ago we did 625, but let's say you forget. Oh, there it is, still on my calculator, so that's 5 to the 4th. Cancel out the 5's, that leaves me with 2 times 2x equals 4 times x plus 2. Multiply these, 4x. Distribute here, 4x plus 8. Now use basic algebra, get like terms together. This gives me 0 equals, that cancels out, and I get 8. Okay, this is a problem. This kind of happened before. Sorry if I just made noise on the microphone. When the variable completely cancels out, there's no variable left. If you have a true statement, we call that all real numbers. On this problem, the variable completely canceled out, but does 0 equal 8? No, that's a false statement. That means there is no solution here. And that is the symbol for no solution. So let's check 14. And there it is, no solution. Okay, number 16. No, number 16 happens to have a 16 in it. Well, we want these bases to be, oops, hey, notification. We want these bases to be the same. I can turn a 16 into a 4. Don't you know that 16 is 4 squared? So that's good. Now we want these things to work out. So how do I make this a regular number instead of a fraction? Use the negative exponent rule. That's 4 to the negative 2. And then what about this one? Well, what power is on that 4? If there's no power on a number, it's automatically a 1. So if I do the negative exponent rule to make it a regular number instead of a fraction, a whole number instead of a fraction, I'm going to have to make that a negative 1. Now I can cross these out. Negative 2a plus 3 equals negative 1. Distribute there. Negative 2a minus 6 equals negative 1. Add 6. Come over here. I get negative 2a equals, what's that, 5. Divide by negative 2. Negative 5 halves, negative 2.5, negative 2.5, whatever you want to call it. Let's check the answer key and see what they did. Negative 5 halves. All right, we're really rolling. Okay, next one. Now, can we just cross these out, one-to-one rule? No. You can cross out one thing on one side with one thing on the other side. So it's the one-to-one, not the two-to-one rule. So we need to combine these bases. Just like in the notes a few minutes ago, I said when you multiply like bases, you add the powers. So that's an important rule to know. When you multiply like bases, you add the powers. So this is going to turn into, here, I'm not going to do it in my head. I'm going to write it out. Combine the bases. I'm going to need to add the powers. Negative 3p plus negative p. Right there. What is negative 3p plus negative p? That's negative 4p. Now that I have one base on each side, they will cancel out. The one-to-one rule. Negative 4p equals p minus 1. And from here, it's fairly basic algebra. I'll subtract p on both sides. Negative 5p equals negative 1. Divide by negative 5. Cancel out. And those negatives also cancel. I should get 1/5 for an answer on number 18. And there it is. All right, so if you, going through algebra, you learned how to solve equations. It became very easy. So this is new, possibly a whole new challenge for you in solving equations. Number 20, again, we need to combine like bases. So this is going to become 6 to the negative n minus 1 plus n plus 3. So I need to take this power and add it to that power. But over here, I also need a like base. So I can't have 216. Let's see how many 6's I have to multiply together to get 216. It takes 3 of them. So this is 6 to the third power. So I get 6 to the, all right, ooh, what's going on here? Negative n plus n cancels out. Negative 1 plus 3 is 2. These cancel out. I get 2 equals 3. Okay, no variable, so that means it's a special situation. If it's a true statement, it's all real numbers. If it's a false statement, it's no solution. This is a false statement. So number 20 is no solution. Let's check. And there it is. All right, number 22, and we are done. So number 22, we need to combine bases. So the rule for dividing, see that fraction bar there means divide. When dividing, you keep the base and you subtract the powers. So it's top, subtract, bottom. And now we need to work this out. So that's negative 3v minus 3 minus 1 plus 2v. And negative 3v plus 2v is negative v. Negative 3 minus 1 is negative 4. But now we get to a point where we don't have like bases. So we got to change them into the same base. I'm going to see if I can multiply 3's together to get 27. And there it is. Oops. 3 to the negative v minus 4 equals 3 to the third power. Those cancel out. Negative v minus 4 equals 3. Add 4 to both sides. Negative v equals 7. Let me come up here. Divide by negative 1 to cancel out that negative. V equals negative 7. Let's check 22. And there it is. Okay, this is all attainable. This is all stuff you can do. You've been solving equations since 8th or 9th grade. Most of the steps you already know. At its heart, the one-to-one property is super easy. You have the same base on both sides. They just cancel out. It gets tricky when the bases are different, but there's always some way to do it to make them the same. Or it gets tricky when you have to combine like bases to make them one-to-one. But again, it is something that you can do. And when you get the fractions, the whole negative power thing can be tricky as well. So I've used the word tricky about 1,000 times. Maybe you're going to find it simple. I don't know. But if you don't, let me know. I will help you in our Google Meets. I will set up an appointment one-on-one with you. One-to-one. or just answer questions through email. So good luck. Let me know if you have issues. Talk to you.